This week on Green Science Oregon, we're taking a look at biofuels as a temporary solution to petroleum-based fossil fuels. Researchers at Oregon State University are looking into ways to convert leftover biomass like grass, straw seed, and forest debris into ethanol. Two OSU students will show us how biodiesel is produced using a biodiesel demonstration cart. And we'll take you to Sequential Pacific Biodiesel in Salem, where biodiesel is produced from used cooking oil and distributed throughout the Northwest. All coming up next on Green Science Oregon.
Quite some time ago, if you look in your history books and learn about a fellow by the name of Rudolf Diesel, he's the one that basically invented the diesel engine that well, not like what we have today, but the beginning of the diesel engine. And at that point, he developed this engine that would work without spark plugs, and peanut oil was readily available to him. And it turned out that peanut oil, under the right conditions of heat and pressure and mixture of oxygen, can self-ignite, and that produces the diesel effect, which is the process of diesel operation. That happened back near the turn of the 1900s. And since that time, of course, diesel engines have been significantly improved. They're much more efficient than they were then. But fundamentally, it's the same process, and one can actually run a diesel engine on vegetable oil, but you can't do it at room temperature. The engine has to be hot. So you can't just fill your tank with vegetable oil and start the engine. It won't work. However, some people do run diesel engines on vegetable oils after they're heated and operating. So that's kind of how diesel engines started off, and they are more efficient than gasoline engines, and still are. And that's because of the fact of thermodynamics. They have a higher temperature cycling process, and therefore they get more energy delivered to the mechanical part of the system than a gasoline engine does. Biodiesel is a compound that can run in a diesel engine. It turns out that diesel engines started off on peanut oil, not diesel, and diesel is synthesized from petroleum in a process that's fairly well known but fairly lengthy. Biodiesel, one takes vegetable oil and a strong base and some alcohol and mixes those together, and you end up with a material which is a ester of the oil. So quite often you'll hear it referred to as fatty acid methyl ester, or FAME, but that's biodiesel. So it comes straight from either vegetable oils, or it can come from animal waste products too, and then a little bit of alcohol.
My name is Michaela Leslie, and I'm a student at Oregon State University, and I'll be showing you the biodiesel demonstration cart. So to make biodiesel, you need three things. You need vegetable oil, methanol, and lye. So first, you add the methanol and the lye, which is the catalyst, into the Illimer flask right here. And then you transfer it into the reactor right here with the vegetable oil that's in the source container here. So everything goes into the reactor, and this mixes, and in the end you get biodiesel and glycerin from that. You need to separate the glycerin off of it because the glycerin is a byproduct, and you do that by moving it to the separatory funnel. And the separatory funnel makes gravity separate the glycerin and the biodiesel. So the glycerin is going to be at the bottom and the biodiesel is going to be at the top. The biodiesel will then be transferred to the wash station, where water will be sprayed from the top. And this is done because the catalyst is still in the biodiesel, because the catalyst is not used in the reaction. And so the water absorbs the catalyst, and then to get rid of the catalyst in the water, you have to move it to the drying column, where the water and the catalyst are removed. And then in the end, once all the water is removed, you can bring it back here to remove it to the separatory funnel to remove any excess water. And then in the end, you have biodiesel that you can run in your car.
In addition to the biodiesel demonstration cart, students at OSU also participate in an outreach project that teaches elementary through high school students about biodiesel production.
For younger kids, we'll usually make soap with them using a glycerin soap base, and the reason we do that is because a byproduct of biodiesel, the main byproduct, is glycerin. which actually separates out due to a higher density. Once you siphon that off, then you're able to make soap out of it. Another activity that we do with the younger kids and the older kids is that we make biodiesel in little vials. So we usually add the methanol and the lye ahead of time, like this. You can tell that there's lye in it, it's milky looking. And then we just have them measure out the oil and add it. You want to be exact if you're going to put it in your engine because you don't want to have a lot of leftover methane or lye. And after shaking it for about 15 minutes, they wind up getting biodiesel, and they let it separate out, and then you can distinctly see the glycerin and the biodiesel layers. So you can tell visually that a chemical reaction has happened. Another activity that we do is the cloud point test. We do this with both the young kids and the older kids. We made biodiesel out of 4 different types of oil, and the kids take samples of these different types of biodiesel and put them into test tubes, put those in ice, and just see which biodiesels go solid, which ones cloud, and which ones don't do anything, they just stay clear. This is the unreacted vegetable oil and methanol with the catalyst in it. This is after it's been shaken, and this is after it's completely reacted and separated into glycerin and biodiesel. The last one that we only do this one with the older kids. It's a titration. We use used oil. This oil came from the McNary dining hall. It was very used. Used oil is more acidic than clean oil because free fatty acids are released when you fry the food. And so you need more of the catalyst, sodium hydroxide, which is very basic. You need more of the catalyst when you're reacting oil into biodiesel. We have them use phenolphthalein, which is an acid-base indicator. And we also have them use pH strips just so that they get experience with both. And then we have them dissolve a little bit of the used oil in isopropyl alcohol and start the titration.
Green Science Oregon is brought to you by Oregon State University, where faculty, students, and research are powered by Orange.
This biodiesel that's filling this tank comes from Pacific Biodiesel facility. I believe it's the one that fills this tank is probably the one that's located in Salem. And they actually produce their biodiesel, I believe, predominantly from oil that they get from the Kettle Chips Company.
Sequential Biofuel started 10 years ago in the garage with a 55-gallon drum on a boat motor, and I still have all my fingers today. One of the reasons that attracted us to biodiesel is the notion of energy independence and community scale. We could collect our own feedstock and make our own fuel and run it in our own cars, and it was really empowering. When you buy this, it's scratch and sniff. You put it in your tank, you're going to hear a difference. Your car's going to quiet down. The tailpipe, the smoke is going to turn more of a white than the big black plumes, more completely combusts the fuel, and it's going to smell different. Throughout the country, there's a strong movement of home brewers. That said, there's a big difference in making a little bit of fuel at home and scaling up to a commercial scale facility. It is labor intensive. There's hazardous materials that are involved, like the methanol that has lots of safety precautions, and there's some waste streams. The glycerin stream that comes off of making biodiesel needs to be refined further to be made into usable products, and so there's considerations for those homebrewers about how they handle those co-products. We're able to handle everything safely here, take care of our team, as well as make good usable products. We specialize in community scale biodiesel production. That means we focus on feedstock that is available locally. Recycled cooking oil is our primary source for making biodiesel. We try and collect it within Oregon and Washington, and we try and sell that product as close as we can to the end user. If you think about the way a fuel shed works, there's large tanks in Oregon, at least on Highway 30 in North Portland. That product comes in by barge and by rail and pipeline to there, and then it goes to rail car and then truck and trailer and distributed all throughout the state before it gets to that individual car. We try and go direct as possible into that individual driver's fuel tank. We make biodiesel through a process called transesterification, where we take a raw gallon of cooking oil straight from a restaurant, we clean it up by separating out, say, hash browns or French fries, other mess, we dry it out, and we get it so it's what we call reactor-ready oil at that point, which is similar to a virgin cooking oil you'd use in your kitchen. We load that into a reactor, we mix it with potash and methanol, agitate it and heat it for a period of time, and it causes the glycerol molecule to break off, and then you have two products, one's glycerin and one's biodiesel or methyl ester. Then we go through a series of purification and filtration to clean up that biodiesel and do some independent testing analysis on it. Once it's approved for sale, we send it out to market and it's ready to go in vehicles. Sequential Pacific's footprint really is the Pacific Northwest, and we believe this plant is appropriately sized to capture about 50% of the cooking oil in this region.